All right, so let's go ahead and take a look at some multi-step equations and how to solve them. So multi-step equations are usually more than two steps. So it could be 3, 4-step equations. And let's just jump right into some examples here and take a look at how to do them. So we have here negative 34 equals v plus 42 minus 5v. And I recommend that at each equation, you pause the video, try to solve it yourself, and then unpause to see if you get to the same solution that I do. Okay, so here you notice that we have a v and a negative 5v, and they're both on the right side of the equation. Since they're both together on the right side of the equation, what we can do here is we can combine like terms. Remember, if one of these was on the left-hand side of the equation, over here in front of the negative 34, then we would not be able to combine them, because they're not on the same side. But these are, so we could put them together. Remember, this could help some of you to remember that in front of this v, there's an invisible 1. And so when we combine these together, 1 minus 5 is negative 4. So 1v minus 5v is negative 4v. Copy down the rest of this equation, plus 42 on this side, and on this side, a negative 34. And here, each step you perform, you get to a simpler equation. This now is a simple two-step equation from this point on. So we know that our next step is to undo addition or subtraction. So we have to get rid of this plus 42. And the way we're going to do that is subtract 42 from both sides. 42 minus 42, remember we call this additive inverse. A number plus its opposite equals 0. So that's why these cancel out, leaving me with a negative 4v on the right-hand side of this equation. And on the left, negative 34 minus 42, they're the same side, so we're going to add them together and keep the sign. So negative 34 minus 42 is negative 76. And so finally, there's one step left. We see here that v is being multiplied by negative 4, and we need to undo that, so we're going to divide both sides by negative 4. These cancel out here because negative 4 divided by negative 4 is 1. And that's what we want. We want 1v. And on this side, negative divided by negative is positive, and 76 divided by 4 is 19. All right, so let's take a look at this second equation. 42 equals 3 times 2 minus 3h. And you see that we have a 3 here right next to this parentheses, and inside we have 2 minus 3h. This can be read as 3 times the difference between 2 and 3h. And so whenever we have this setup, okay, we need to distribute the multiplication of 3 to each term inside the parentheses. We call that the distributive property. So let's go ahead and start. We'll say positive 3 times positive 2 is positive 6. And then the second term, positive 3 times negative 3h is negative 9h. And copy down the rest of the equation, 42. And again, our next step is we have to get rid of addition or subtraction. Now don't get confused here. Some students will take a look at this negative and think that they have to undo subtraction. But that's not who we're getting rid of yet. This negative shows me that this is a negative 9h. And that's multiplication. Our first step is to undo addition or subtraction. So this 6 is just sitting here, and it's being added to negative 9h. So that's what we're getting rid of. You always have to look in front of the number you're trying to eliminate to determine the sign. There's nothing in front of the 6. That makes it positive. So we need to subtract 6 from both sides. These cancel each other out, leaving me with a negative 9h on the right-hand side. And on the left, we have a 42 minus 6, which is 36. And then our last step is we need to eliminate this negative 9. And this negative 9 is multiplying h, so we need to undo multiplication by negative 9. So we need to divide both sides by negative 9. Negative 9 divided by negative 9 is 1. So we end up with 1h, which is what we want. And here, positive 36 divided by negative 9 is negative 4. Okay, let's move on to the third equation here. Now this third equation is interesting because it is made up all of fractions. And many students do not like to work with fractions. So there's a little trick that we can use to convert this equation so that there are no fractions. And that's called eliminating the fraction. The way we need to do this is by looking at the denominator of each term. We got the 5, the 10, and the 20, and to come up with a least common denominator. So for 5, 10, and 20, the least common denominator would be 20. And what we're going to do with that is we're going to multiply, okay, the entire equation by 20. We're going to distribute multiplication by 20 to all three terms in this parentheses. Okay, so I'm just going to show you by writing one of these out completely how that works. So let's just do real quick 20 over 1 times the first term, x over 5. Okay, and so if you remember about your cross simplifying, I can divide 20 and 5 by 5, leaving the 5 to be a 1 here and the 20 to be a 4. And since the bottom here is all ones, okay, that means you end up with a whole number. Whenever you have a fraction with a 1 as your denominator, you end up with a whole number. So really, all we're left to do here is 4 times x, and that gives us the term 4x. Okay? And so that's how all of these work. The reason why we try to get the lowest common denominator of 20 is because that means I'm going to be able to divide 20 by each of these denominators, by 5, by 10, by 20. And I will be able to turn or convert each one of these denominators when I simplify into a 1, which is how we turn these fractions into whole numbers, okay? So I'm just going to go ahead and erase this and start back from the beginning of the process, but this time without writing it out full, okay? So the way you think through this is, let's take a look at the first term, 20 times x over 5. And so you ask, what's 20 divided by 5? 4. So 4 times x is 4x. So now let's move on to the second term. This time we have a 10 as our denominator. So we ask, what's 20 divided by 10? And that's 2. And 2 times negative 3 is negative 6. And then finally, the third term here on the other side of the equation, 20 divided by 20 is 1, and 1 times 9 is 9. And look, we've taken this equation and we've converted it so that it has no fractions. Both of these equations are equivalent to each other. They have the exact same value. It's just one looks a lot easier to work with because we've eliminated the fractions. So let's go ahead and continue with our steps. Undo addition subtraction, so I have to get rid of negative 6. I'm going to add 6 to both sides. Negative 6 plus 6 cancels out, leaving me with a 4x on the left, and 9 plus 6 is 15, a 15 on the right. And finally, last step here, divide by 4 on both sides. These 4's cancel out, and x equals, and you could write exactly this, 15 over 4. It's okay for your answer to be an improper fraction so long as it is in simplest form. Now if you wanted to convert it to a mixed number, you can just go back to the old days of long division where you learned, okay, well, 4 goes into 15 3 times, and 4 times 3 is 12, and 15 minus 12 is 3. And then that 3, you know, when you first learn this, you say 3 remainder 3, but then you learned that instead of saying remainder 3, the 3 down here becomes your new numerator, and 4 stays as your denominator. So 15 over 4 can also be written as 3 and 3/4, and many of you will take it the next step or use a calculator and just write 3.75. All right, so let's go ahead and take a look at our next example here. This is an example of an equation that has variables on both sides. If you look to the left side of the equation, we have a 4t, and on the right side we have a negative 8t. So since they are on opposite sides, we cannot combine like terms. We need to eliminate one of these variables. Because remember, The goal for solving an equation is to isolate the variable, which means to get it alone on one side of the equation. So we have to get rid of one of these. And the easiest path is always to eliminate the variable of lesser value. So some students might get confused and go immediately to the 4 and say, well, 4 is less than 8. But take a close look. This is not an 8, it's a negative 8t. So negative 8 is less than positive 4. All negatives are less than any positive. So we're going to go ahead and eliminate negative 8t. And remember, the way you eliminate the extra variable is by doing the opposite operation. So if it's positive, you would subtract. If it's negative, you would add. So I need to add 8t to both sides here. Okay, negative 8t plus 8t, this cancels out. On the right hand side, I'm left with a negative 13. And here 4t plus 8t is 12t. And we still have this plus 9. So now our equation has become 12t plus 9 equals negative 13. So we move on with our steps that we already know. Undo addition here. We have to undo positive 9, so we need to subtract 9 from both sides. These cancel out here, leaving me with a 12t on the left-hand side. And negative 13 minus 9, same sign, add them together and keep the sign. This is a negative 22. Okay, so now, last step, divide. We have to undo multiplication by 12, so we have to divide both sides by 12. Okay, and the same thing can happen here. You can take a look at this equation, negative 22 over 12, and say, well, that's my answer. It's okay to have an improper fraction. However, negative 22 over 12 is not in simplest form. I could divide both of these pieces, okay, the numerator and the denominator, by 2, giving me a negative 11 over 6. Now this is a proper answer. So I could say t equals negative 11 over 6. Or if I wanted to convert it to a mixed number, 6 goes into 11 one time, so this would be negative 1, and 11 minus 6 is 5. So negative 1 and 5, 6. All right, so let's go ahead and take a look at this second to last example. This is another example of an equation with variables on two sides. But as you can see here, first we need to go ahead and apply the distributive property. So let's get to it. Negative 2 times j is negative 2j. And then negative 2 times negative 3 is positive 6. We'll bring down the other side and we see negative 2j plus 6. And so what you might notice here is both sides of this equation are exactly the same. So if both sides of the equation are exactly the same, think about if you pick a number and substitute it for j, will you ever end up with an untrue statement? Remember, if you work an equation out, you substitute a value and you work an equation out, and you end up with the same number on both sides, that's a true statement. So is there any number that you can choose for j that would make this a false statement? Well, let's look at a few. What if I substituted 0? Well, negative 2 times 0 plus 6 is 6. And since the right side is the same exact thing, I would end up doing negative 2 times 0 plus 6 is 6. Okay? Any value that I choose for that would work out exactly the same. If I choose, oops, I went too far here. Here's my 6. If I choose 10, well, negative 2 times 10 is negative 20, and negative 20 plus 6 is negative 14. The same exact thing would happen on this side. Okay? So hopefully you can see what it is that's taking place here, is that this equation, no matter what you write, is always going to be true. No matter what value you choose for your variable, j, it's always going to be a true statement. And so I'm just going to go ahead and show you what it looks like when you complete the steps of solving a two-step equation, right? I lost the 6 again. Anyways, so I have to get rid of one of these variables, right? Since they're both negative 2j, it doesn't really matter which one I get rid of. I have to add 2j to both sides. When you do this, well, negative 2j plus 2j cancel. Negative 2j plus 2j cancel. And I'm left with 6 equals 6. And that's a true statement. Okay? So that means no matter what value we pick for j, we would end up with a true statement. And what we call this as an answer is infinitely many solutions. Because again, what that means is you can choose any number you could think of and substitute it for j, and when you work out both sides of the equation, you would end up with the same number on both sides, which tells you a true statement. So that's what that means. Okay? So when you work on an equation like this out, and both variables on both sides end up getting eliminated, and you end up with a number equals itself, that is infinitely many solutions. All right, so let's take a look at our last example here, which is pretty much a counter example. It's the opposite of this. So we could take a look at how this works. We have distributive property on the right-hand side here. So let's go ahead and say 5 times x, that's 5x, and 5 times negative 3, that's negative 15. And on the other side, we have 5x plus 10. Okay? So if you look carefully at this, you'll see that both sides have a 5x, but the left we have plus 10, and on the right-hand side we have minus 15. So since both of these are 5x, whatever value you choose for x, you're going to get the same number, right? So let's say you choose 10. Well, 5 times 10 is 50. Same thing over here. 5 times 10 is 50. Correct? But when you do 50 plus 10, do you get the same answer as when you do 50 minus 15? No, obviously you don't, right? So what this points to is the fact that whereas this equation on the left is always true, this equation on the right is never true. It's impossible for 5x plus 10 to ever equal 5x minus 15. Okay? And so that's what's going on here. Let's just go ahead and finish the steps so we can see what that looks like. Okay? So we're going to go ahead and we have to get rid of 5x. So we're going to subtract 5x from both sides. And both of them end up canceling each other out. And we end up with 10 equals negative 15. So does 10 equal negative 15? Absolutely not. So whereas this one was a true statement and would always be a true statement, this one is a false statement and would always be a false statement. So instead of the answer being infinitely many solutions, the answer to this equation is no solution. Because there's no possible value that you could choose for x that would ever make this true. So that's why we say no solution. All right, I hope that these examples helped you to understand how to solve some multi-step equations.